Subho Vijaya and happy Dussehra to all of you. Okay, so we meet after we meet after some days. Okay, so as promised, this is the video and this is the class for the upcoming GATE exam. Okay, and we starting from LPP. Okay, since LPP is a very important topic and the weightage of LPP in the GATE exam is very good for the GATE exam. Okay, and this LPP topic is also important for the CSIR NET exam and SET exam. Okay, so we started from LPP. Since in the questions paper of GATE 2022, I think there was 6 to 7 questions. Okay, I think 6 or 7 questions asked in GATE 2022. So you can think the weightage of this topic, that is LPP, in the GATE exam. Okay, so let's start today. And before starting, I am requesting you to all those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and don't forget to subscribe the channel. Okay, so first we see the syllabus of the LPP in the GATE exam. Okay, so this is the syllabus. Okay, linear programming, models, convex set, extreme points, basic feasible solution, graphical method, simplex method, two-phase method, revised simplex method, infeasible and unbounded linear programming models, alternate optima, duality theory, weak duality and strong duality, balanced and unbalanced transportation problems, initial basic feasible solution of balanced transportation problem, least cost method, northwest corner rule, Vogel approximation method and optimal solution, modified distribution method, solving assignment problems, and Hungarian method. So the syllabus is a big syllabus for the GATE exam. Okay, and my guess was in the last exam there was the questions from northwest corner rule. Okay, so I guess this topic, in that the questions can be made from this topic, and it is happened. Okay, that is, my guess was sure, my guess was true, and there was a questions from northwest corner method. Okay, so we start from basics, very basics level, and we are trying to go to the up to a standard level of these topics. Okay, so let's start first with the definition of LPP. Okay, so what is the definition of LPP? This is a simple, I just skip these topics because the questions, we are focused only the main topics from which the questions of GATE comes. Okay, so just see it once. So see, a mathematical programming can be written as optimized z equal to f of x1, x2, xn, and subject to the conditions g1 of x1, x2 and xn. This is greater, less, greater and equal to b1. This is the three sign. Okay, greater equal to or less equal to. Okay, these three signs together in this sign. Okay, and then g2 of x1, x2, xn, this sign greater equal to or less equal to b2, and similarly up to gn of x1, x2 and xn up to bn. Okay, so the function, this f function is called the objective function, and the condition 2, this is the total condition 2, is called the constraints. Okay, and x1, x2 and xn are called the decision variables. Okay, and b1, b2, bn are called the requirement parameters. Okay, so this is a complete definition of an LPP, and we all know that the LPP is needed for what? For basically business purpose. Okay, so this is basically the problems from business purpose, you can say. So let us take an example first, how to make an LPP, or how can we formulate an linear programming problem. Okay, so see, for an example, I take a very easy example to see it, just that is, you can, if you you can understand easily. Okay, so let us take the example. A factory is engaged in manufacturing the three products A, B and C, which involves lathe work, grinding and assembling. Okay, so the cutting, grinding and assembling times required for the units are 211 hours respectively. Similarly, that is the time for the product B is 3, 1 and 3 hours for the one unit of B, and 1, 3 and 1 hours respectively for 1 unit of C. Okay, so the profits on the ABC are 2 rupees 2 and rupees 4 per unit respectively. Okay, assuming that there are available 300 hours lathe time, 200 hours of grinding time and 240 hours of assembling time. Okay, so pose and linear programming problem in terms of maximizing the profit on the times of manufactured. Okay, and after so see this first. Okay, so how can we formulate this LPP? Okay, so first we write the given information in a tabular form. It is very then we can very easily formulate the linear programming problem. Okay, so first we have to understand what is given, and we have to understand the proper given information, otherwise we can't make the LPP. Okay, that is the linear programming problem. Okay, so first we write the given information. So see, there are three products A, B and C. The cutting time are given for A, B and C are 2 hours, 3 hours and 1 hour. See, this is the given information. 2 hours, this is 2 hours, 3 hours and 1 hour. Okay, 2 hours, 3 hours and 1 hour for cutting time. Okay, and then the grinding time is for A, this is 1 hour, for B this is 1 hour, and for C this is 3 hours. Okay, so this is the grinding time 1, 1 and 3. Okay, and then the assembling time. Okay, so this 1 hours for A, 3 hours for B and 1 hours for C. Okay, so this is the assembling time 1, 3 and 1. Now the profit is from 1 unit of A, the profit is rupees 2. This is in rupees. Okay, and for 1 unit of B the profit is 3, and for 1 unit of C the profit is rupees 4. Okay, and available time for cutting is total given 300 hours, for grinding it is 200 hours, and for assembling it is 240 hours. So we have to maximize this profit. Okay, in this available times. Okay, so that is the maximum time which is available is 300 hours. So it is clear that from this it is clear that the constant must be is of less equal to type. Okay, because this is the total, that is this is the maximum hours, that is this is less equal to 300 or 200 or 240. This type of problems can be made. Okay, so let the manufacturer produce X unit of products of A. Okay, and Y units of product of B and Z units of product of C. Okay, and then the objective function is maximum of W. This is equal to, we have to maximize the profit. Okay, so the total profit from A is 2x, total profit from B, product B is 2y, and the total profit for C is 4y, 4z. Okay, this is the total profit. I think profit 2 and 4. So this will be, I think, 2. Okay, so this is the total profit. So we have to maximize the total profit of this company, for the company. Okay, so the constants in view of cutting, grinding and assembling, these are makes the constants. Okay, so the cutting, grinding, for the cutting, grinding and assembling, so this is the cutting time for A, this is the total cutting time for B, and this is for C. Okay, so C, product A, cutting product for product A, cutting, grinding and assembling, total time available is 2, 3 and 1. Sorry. For product A, B and C, total cutting time is 300 hours. Therefore 2x is the total cutting time for A, 3x is the total cutting time, 3y is the total cutting time for B, and Z is the total cutting time for C, and total cutting time available is 300 hours. Therefore 2x plus 3y plus Z is equal to 300. This is one constant. Okay, now total grinding time is, for A this is X, for B this is Y, and for C this is Z. Okay, so this is sum is the total grinding time, and the maximum hours is 200 hours. Therefore X plus Y plus 3Z is equal to 200. This is the second constant. Okay, and the third constant is for the assembling time. Okay, so this is the total assembling time for A, this is the total assembling time for B, and this is the total assembling time for C. Therefore the total assembling time is this sum, and the maximum time, that is maximum hours available for assembling, is 240. Okay, so this is the third constant. Okay, so this is we have formulated the LPP. Okay, therefore the required LPP is max W equal to 2x plus 2y plus 4z, that is this is the objective function, this one, and these three are the constants. Okay, and obviously x, y and z satisfies the non-negativity condition. Okay, so this is the first day's lecture. Okay, just a simple lecture on the definition of LPP, and let us take an example and then you can understand easily that this is how can we make the LPP. Okay, then after this lecture we go to the inside of this LPP, different topics and most important topics for gate. We can here we discuss the most important topics for gate and the previous year questions of gates. And okay, so this type of discussions we make here. Okay, so this is the lecture for today. This is a small lecture. So how was the lecture? If the lecture is helpful, then please give a like to this video, share with your friends and subscribe the channel. Okay, thank you. See you again in the next video.